Today we are going to see about a simple sorting algorithm called bubble sort. First I'll tell you what is the definition of bubble sort. Bubble sort is a simple sorting algorithm that works by repeatedly swapping the adjacent elements to get in order, maybe in ascending order or in descending order. And we'll see the implementation of bubble sort in Python. First, I'll explain what is bubble sort and how it works with a simple example, and I'll tell you the both optimized way and non-optimized way. First, I'll start with the non-optimized way. Let us assume that we have a element, four elements in an array or a list. Okay. And the elements are 4, 3, 2, 1. And now we are going to arrange this in the ascending order. Okay. Now, and these elements are arranged in the index position 0, 1, 2, 3, starting from 0 to 3. Now we can and before that we have a condition to swap these elements to get in order. So we have a condition, and the condition goes this way. Let us assume that this array is A. and and this is our main condition for swapping. Okay, it says that if the before number, let us assume I as 0. Okay, let us assume a of I means the 4 is greater than a of I plus 1. 0 plus 1 is 1, so a of 1 is 3. 4 greater than 3, we know that it is true, so we go for swapping. I'll just write the pseudocode swap. Else, just continue. Okay, now we have seen the condition. Okay, now we have seen the condition, and this is a small pseudocode of bubble sort. And okay, we'll see how it works in the real cases. As I said before, 4 is greater than 3, so we'll swap 3 and 4. Then check for 4 and 2. 4 is greater than 2, so we'll swap those numbers. We'll get 2 comma 4. Then we'll again check for 4 and 1. 1 will be greater, means 1 will be lesser than 4, so we'll swap it again. As you notice, this is a completion of pass 1. At the end of pass 1, at the last stage of pass 1, we'll get the largest number at the last position, as we are doing ascending order sorting. And then we come with then we go to pass 2. Then we'll check 3 comma 2. No, it satisfies the condition, so it swaps. Then again 3 comma 1, so it will be swapped as 1 comma 3. 3 comma 4. As I already told you that pass 1 at the end stage will have the greatest element at the last position, so there is no need for this step to compare this, so it is an unnecessary step. Then again you can see in pass 3 we'll compare 2 and 1. As the condition is true, we'll swap it. You can notice that at the first swap of pass 3 itself we got the answer, but these two are unnecessary, and we have an optimized way for reducing that. Okay, now we'll see the code for non-optimized one. Okay, and this is the code for a non-optimized one. Here I declare a function n equal to len of the array given for I in range of n minus 1. This I represents the pass, and the nested J loop represents the iterations inside the pass. Okay, then we have our condition if a of j is greater than a of arr of j plus 1, we'll swap it. This is a syntax we use to swap in Python. Then after swapping all the elements, we'll just print the array, and this is our driver code. And this list of map of int comma input of dot split off is the method we use to get elements in separated form, and we'll call the bubble sort function. Okay, I'll just execute and I'll show you. 4 2 1. You can see we got the answer 1 2 3 4. It is sorted. Now see how many steps it takes to sort. If you can see, it takes totally 9 steps from here to here. Sorry, from here to here. And as I already told, there is already a base of iterations in this non-optimized method, and we'll see how to solve that problem in the optimized method. Same like non-optimized method, it works the same. This will be swapped, again this will be swapped, again this will be swapped. We'll get the largest element at the end, and then it'll check it. This condition will, this elements will be swapped, then this one, and you can see only in pass 1 we have 3 iterations, in pass 2 we have 2 iterations, and in pass 3 we have only 1 iteration. So we can reduce that iterations. As I said, iteration, we can make changes in the J loop. Okay, you see here, if we have in our J loop, if we change the condition as n minus I minus 1, at the first iteration, at pass 1, okay, let's take at pass 1, the I value will be equal to 0. So we automatically know the total array size is 4 minus 0 minus 1 equals to 3, and we can clearly see that we have only 3 iterations inside pass 1. Then pass 2, we have I equal to 1, because in the for loop I will be incremented. So 4 minus 1 minus 1 equals 2, and you can clearly see that we have only 2 iterations in pass 2. Then again in pass 3 we have I value equal to 2, so 4 minus 2 minus 1 equals 1. You can see we have only 1 iteration in this pass 3. And see here, I have made changes in this code here, and let's execute example. It is sorted, and we'll see how many steps it takes to sort. It totally took 9 steps in this. 3 into 3, yeah, 3 into 3, it's 9. And you can clearly see we have a less number of steps, 3, 5 and 6. In that we had 9, and in this we have 6. Okay, for example, it is comparatively less, If imagine that you have 100 elements or 1,000 elements in an array and you need to swap it using bubble sort, this non-optimized with method will take more time. Then we have the lost optimization. Imagine that we have a number 1, 2, 4, 3. In this we have totally 4 elements and only this thing should be swapped. But as we know in our previous example, even if we swap these two, there will be many unwanted iterations. To stop that, we use a flag. When the flag equal, we'll just assign inside I loop flag equal to 0. If no swap is done, we can clearly understand if no swap is done, there is no need to we can if no swap is done we can immediately return the result. So when the swap is done we'll change it as flag 1. If swap is not done we have a condition here. If flag double equal to 0 return ARR. So then we'll get the answer in a more simplified way. Thank you. And this is for today. We'll see selection sort and other sorting algorithms in next video. Thank you.